You already know Java, but knowing Java and getting hired to build your system, that's a completely different game. And the one thing standing between where you are now and a job at a company that actually pay well, it's Spring Boot. This is the framework, the one every serious backend developer need to know, the one on every job description that matters. Netflix run it, Amazon build with it, and the developer who knows it, well, they don't struggle to find work. Companies comes looking for them. In this course, you're going to learn Spring Boot the right way. No reading documents, no watching slides. You're going to build real application, write real code, and by the end of it, you will have the skills that most Java developers spend years trying to get. This is your shortcut. So, if you are got the Java basic and a serious ambition to level up, stays in because what you are about to learn will change your world. So let's build.
Real quick, think about every business owner you know, the restaurant, the consultant, the coach, that local business trying to grow online. Most of them have a website. Most of those websites are doing nothing. They look like they were built in 2012. They don't convert, they don't represent the business, and the owner has no idea of how to fix it. That gap, that is literally why you are learning this, because businesses need people who can build things that actually work and actually look the part. Polaris is a studio that serves exactly those businesses. They build, design, and experiences for companies that are serious about their digital presence. No templates, no drag and drop, real work, built from scratch, build to convert. If you know a business owner in that situation, or if you are building something yourself, send them to the Polaris.studio website. It's the kind of work that reminds you what's possible when design is taken seriously. Link below. So, alright, let's go back into the course. In this course, we will use IntelliJ IDE as it the best code editor for our job. So let's start by creating a new project and let's give it the name of the Ultimate Spring Boot course. We will use Java and Maven for our package manager. We will use the group name of Polaris.springboot and you can change the other settings as well. Let's click next. Now this Windows is for dependencies, for adding special dependency to connecting to the web, for security, to connect to databases, etc. We don't need it yet, and we can add those one easily later on. So let's just not worry about it and hit create. Now let's start with the core of Spring Boot. So in this lesson we will talk about dependency injection. Think of dependency injection as a professional chef in a kitchen. Instead of the chef going out to the farm to pick up tomatoes every time they need a salad, someone else delivers the tomatoes right to the kitchen counter. The chef just focuses on cooking and he does not care where the tomatoes came from. That's exactly what dependencies injection does for your code. So let's start with the problem that dependency injection solves. Let's say that we need to send an email. Usually we will add create an email service directly inside our user service. But that's like building a car where the engine is wheeled to the frame. You cannot swap it out. So in the SLC folder, main, Java, let's create our simple email service class. Add it to GitHub. Nice. Now let's add the simple send email method. Public void send email with the simple argument of string message. Great. Let's set something like email and now we will log in the message. Now let's create the user service. This is the class that will use our email service to register new users. Initially we will do it the wrong way by creating the dependencies ourselves. So let's create the user service with the tight bed coupling. So again, new Java class, and let's call this one user service. Hit enter. Now let's initialize the email service in the user service. So private email service, and we will initialize it with the new keyword for the email service. So just like so. And now let's create the register user method that will use the email service. So quickly public void register user. Let's not take any argument, and let's use the email service to send the message. So send email, let's call it user register. This is tight coupling, and it's like having a phone where the battery is glued inside. If the battery dies, you just need to throw the whole phone away. So in code, if we want to swap the email service for the SMS service, we need to tear apart the user service. Alright? So dependency injection fixes it by handing the service to the class from the outside. It's like a removable battery. So we will create an interface to decouple the user service from the email service. An interface is like a contract. It said, I don't care who sends the notification as long as they have the send method. This allows us to swap for different implementation like email, SMS, Slack, and much more without needing to change the user service at all. So let's create the notification service interface. So again, new notification service, and we will use an interface. Click enter, and now let's set the contract for our send method. So we'll use void because the method does not need to return anything. We will call it simply just send, and this method will need one argument of type string call message. So very simply, as you can see. Now let's use the notification service in our email service. So into the email service, now let's make sure the email service will implement it. So implement notification service. You can see the red line, but we will take care of it in a moment, and we will use the annotation service. Shortly I will tell you exactly what does it do. So right here we will use the override, as you already know, and here we have the send method. Nice. Now we override the method from our notification service. So now let's just implement this in the user service. Now you can see all of those red lines because Java don't know exactly where is the send email method or what it does. So let's just swap it all for the private notification service. Let's call it notification service, and we will initialize it by using constructor. So private. So the service annotation is used to tell Spring's context to manage this component for us. Spring will manage this component and inject it wherever we need it, and by doing this we make our job as a developer easier, and we decoupled components from each other. Now the most important part, updating the user service to use the constructor injection. We don't use the new keyword anymore. Instead, we just defined a final field for the interface. So now let's update the user service to use the interface. So let's head over to the user service. We will add the service annotation so Spring could manage it, and we will swap this private field with a new final private field. So we will add here the final, and we'll use notification service to decouple from the email service. Now this is a final field, so it has to be initialized with a constructor. So let's initialize it right now, public user service, and we'll take the argument of notification service, and let's just simply initialize it. Now let's use it in the register user method, use the send method, and let's say again user register. Now as you can see, our user service class is completely decoupled from the email service. It doesn't care if it is sent through email, through Slack, or with SMS. It just knows that it sent a message. It doesn't care with what. And this is quite amazing and the beautiful part of interface. This is all great and anything, but what if you have multiple implementations? Spring needs to know which one to pick. We can use the primary annotation to tell Spring if there is a few components, pick this one. So let's just show you how to do this with the SMS service. So let's create an SMS service, new Java, and let's call it SMS service, and it will implement the notification service, and let's add the service annotation as well. Great. Now let's implement the send method. So override public void send with the string message argument, and let's add to the console, let's log SMS, right? And we can also just send the message itself. So here we go. So right now, if we just run the application, the user service will not know which of those implementation to use, because you have the email service and the SMS service, and it will be confused in which one it should pick for our application. So to make sure that our application doesn't broke for it, we will go to here and we'll add the primary annotation. Now Spring knows that if there is a few components, it should choose the SMS service. And this is kind of the beauty of Spring Boot annotations and dependency injection when it comes all together. As you can see, we didn't need to do much code. We write a little line of code and it was amazing with how much we can accomplish with it. And this is how exactly we make our application flexible, better, and with dependency injection we'll make our application much better for as developer and easier to extend in the future. So this is all for dependency injections, and in the next lesson we will talk about Spring Boot. Now that we understand dependency injection, we need to know how to configure our application. You can think of Spring configuration as a personal assistant that knows all of the settings for your application. You don't want to hardcode database password or your API keys inside your Java code. If you want to change them, you have to rewrite the code and recompile it. In this lesson, we'll learn how to use external configuration to make our application flexible and more professional. Let's first of all start with looking at the configuration file that it is in our application. In the src folder, main, and in the resources folder, you will find application.property. This is our configuration file. Now we can also use another option that uses a YAML file for the configuration, which is much more pleasing to look at. So I'll just show you the differences. So let's create a new file. Let's call it application, and this one will be .yaml. So let's take this property spring application.name and we'll put it in the YAML format. So spring quote application name, and let's just take the name. As you can see, this looks much better than this. This looks way clearer. Now you can have both of those properties files. You can have YAML and properties, but it's kind of hard to manage both of them, so that's why we just use one configuration file for our application. So we can just remove application properties. So we will use the YAML version. We can configure stuff like the port. Usually the port of the application is running on port 8080, but we can change it. Let's say we want the port to run on, let's say, 8081. Or if we want a completely different one from what Spring Boot offer, we can do something like 5000 or anything we want, and just Spring will take it and tell, alright, so I will run it on this port from now on. So we can change a lot of configuration, as you can see, with the YAML file. So yes, now we can add a custom settings to our application, like message that can appear in our application. Next, we can add a custom settings. We will add an app message that can show in our application. Now we can change this message anytime without even touching our Java code. So let's show you how we do this. So let's go app message, and we'll give it a message like welcome to, not like that, no, to Spring Boot. Now we can use this message in our Java code. But how can we do this, you may ask? So the solution is the value annotation. Spring provides us with the value annotation, and we can use it over our variables, and by doing that we can use the properties that we have in our application.yaml file inside our code. So let's check out in the user file to show you how it's done. So we go into the user file, and now we use the value annotation. So we search up for value, and now we will use this format, $, and now we will put our properties like that, app.message. And we need a field, a variable to use it. So private, it's a string of course, and we will call it welcome message. And then now we can use this value in our application. we can create a function that is just like to say hello, like public void say hello. And now we can just simply use our settings. And just like that, we can use the settings that are in our YAML file inside our Java code very simply, very easily, and without a lot of headaches. So this is how we can use in our code with the application setting. Now, one of the coolest things about Spring is that you can overwrite your setting using environment variables. Imagine you're running your application in a high security environment. You don't want to put your database password in a YAML file that anyone can see. It's highly insecure and very easily can be broken and make a lot of trouble. Instead, you can set up an environment variables, and Spring will use that instead of the YAML value. So let's try to overwrite our application message in the terminal. So let's go to the terminal, and this syntax is for macOS and Linux. There is a different syntax to create environment variables for Windows. You can check this out as well, but let's show you how you can do this in Linux and macOS. So you use export, and now you give your environment variables a name like app message equal, and now we can change it like hello from the terminal. And just like that, we can change our settings that we are tells in our YAML file directly from our terminal. It's super useful and it's incredibly important when we're dealing with high secure stuff. Let's say a database password or a secret API keys for special stuff, or your email address. You don't want your email address maybe to be in a plain YAML file that anyone can see and can easily breach. And also security secrets and a lot more can be used in the environment variables. So this is how we can use environment variables. It's just amazing. We just make our application flexible and more secure. And by using external configuration and environment variables, you can now change your application behavior without ever touching your code. And this is just the tip of the iceberg. Now, in the next module, we will talk about SQL databases, and I hope you're ready because we're going to take a deep dive into it. In this lesson, we are going to set up our database. We will be using PostgreSQL, which is one of the most powerful and most popular database for professionals application. But we aren't going to just download an installer and click next, finish, but we are going to do it the pro way, by using Docker. In this lesson, we'll learn how to get our database running in seconds without installing it directly on our computer. So if you don't know Docker, you can think of Docker as a professional standard shipping container for your software. Before shipping container existed, loading a boat was a mess. You had loose bread, crates of different sizes, and things broke constantly. Now, everything goes into one standard box. It doesn't matter if you are shipping to London or Tokyo, the container is the same, and the kernel can move it perfectly. Docker does for you in code. It bundles the database, the settings, and the tools into one box that runs exactly the same on every machine. So now let's create the recipe for our database container, the Docker Compose YAML file. First, we need to create the Docker Compose file. So head over and we'll create it in the root of our application, not in the SRC folder, in the root. So click on here, click on new and file. And now let's call it docker compose.yaml. First, we tell Docker which image to use. An image, it's like a blueprint. We want the official PostgreSQL version 16 blueprint. So now let's define the database services, alright? So let's start with services and PostgreSQL. And the image, my mistake, will be Postgres 16. So we'll put quote and 16. Now we give it a name and start building up our environment variables. These are like settings for our database. So now let's set a container name and the database name. So let's set the container name, and let's call it Ultimate Spring Postgres. So Ultimate Spring Postgres. Now let's set up our environment variables. So not endpoint, environment, and now we need to tell what are calling our database. So let's set it up. So PostgreSDB. We will call it Ultimate Spring Database. I think will be suited. It's great, and we forgot an S right here, so let's just check it out. Great. Next, we need to set up the users and password. We will use simple stuff like user123 and password123 so our application can log in securely. So now let's add those credentials. Very easily, we will call it Postgres user and we'll give it the name of user123, and now for Postgres password, and we will give it password123 as well. Next, we need to open the port so our Java application can talk to the database. The standard port for PostgreSQL is 5432. So let's set it up, ports, and we will use 5432, and we will map it into 5432. Great. Finally, we add a volume. Think of this as an external hard drive for our container. By default, everything inside a container is temporary. If you stop the container, the data is just gone. But with a volume, we mount a folder from your actual computer into the container. This means your data is stored safely on your hard drive. Even if the container is deleted, it's the secrets to keeping your database records permanent. So now let's add the volume mapping, now volume, and now let's talk about the volume, which is postgres slash data var postgresql data. This is the point on the computer that it will keep and store our data. Lastly, we define the volume itself at the bottom of the file. This tells Docker where to store the data permanently. So now let's add the volume configuration. So at the end of the file, volumes, and we tell them Postgres data, and it will know where to store it. Now for the magic, we just run one simple command and Docker will download the database and start it up for us. So let's run the Docker compose in the terminal. So open up terminal, write docker compose app/d, and we will run it, and now it's pulling our database and setting it up for us. Oh my god, man. Amazing, you have just started a professional database in seconds. You didn't have to install anything, and Docker take care of all of that. And now we have PostgreSQL running in our database. And next we will talk about how to make our migration in Spring Boot. In the last lesson, we started our PostgreSQL database. Now we need a way to build our tables. For that we use Flyway. Think of Flyways as a time machine for your database tables. Instead of writing SQL commands manually, you write migration, which are like small instruction manuals that tells Flyway exactly how to build and update your codebase over time. In this lesson, we learn how to use Flyway to build our table safely and professionally. So what is it? Flyway is like a version control system for your database. Just like Git tracks change in your code, Flyway tracks changes in your database tables. If you add a new column today and then new tables tomorrow, Flyway remembers exactly which step you are on. This is a standard way to manage database in a professional team environment. So let's add Flyway dependency to our pom.xml file. So open pom.xml, and now to the dependency level. So we will add this dependency like that. Dependency, and the artifact ID is -core. So fly core, and it's from org.flywaydb. So let's go to here, flywaydb. Now we need to update our Maven dependency so those weird red arrow lines will not be. So you can either shift. Now to get rid of those weird arrow lines, we need to migrate using Maven. So click on this button and wait, and here we go. Now next we need to also add the PostgreSQL driver. This is the translator that let our Java application talk to our database. So now let's add the PostgreSQL driver like we add the Flyway migration. So again, dependency, the artifact ID is PostgreSQL, and the artifact ID is org.postgresql. So org.postgresql. Now we need to add little something that we didn't have in the Flyway migration, which is the scope, which means where does we use it. So scope, and the scope is runtime. So let's click on this button, and Maven will download this dependency to our project. Now we need to tell Spring Boot how to find our new PostgreSQL database. We use the application.yaml file for this. We will add the data source setting, which include the URL, our username, and our password. So now let's update our application.yaml file. So let's go to the application.yaml file that it is in the resources folder, and let's add the necessary stuff. So here we have the Spring application name. So under Spring, we will put our data source. So, and the URL for our database. The URL will look something like that: jdbc at postgresql column local host, and we will put the port and the name that we gave our database, which is ultimate spring db. Next, we add our username and password. We use the same ones that we set in our docker compose file. So now let's finish the data source configuration with the username and password. So username will be user123 as we put this earlier, and password will be password1123 as well. And now we need to add the drive class name to tell which type our database is. So let's do this as well. Driver class name, and we will add org.postgresql.driver. Nice. Now we turn on Flyway and tell it where to find our migration files. We will use the db/migration folder on the class path. So now let's add the Flyway settings. So Flyway column, and let's remove those extra settings, we don't need those. And let's say enabled, set that to true, and locations would set it to the class path, which is db/migration. Oh, there is a double A. Nice. Now for our migration file, Flyway will look specifically at a specific folder called db, and inside this folder it will look out for the folder called migration. So let's create those right now. So in the resources folder, let's create a new directory, and we will call it db and migration. And now it will create a folder. So how exactly Flyway works, how it knows which was the last version. For that, there is a specific format that Flyway are used that looks something like that. So first of all, in this format you have capital V, which stands for version, and then you add the number 1, 2, 3, 4, etc. Now you cannot be in version 4 and then return and say version 2. This is a linear line that it goes, which means you start with version 1 and then version 2 and then version 3. After the version and the number of the version, you make 2 underscore, and then you write the name like initial, which short for init, migration. So migration and .sql, and this is how Flyway works. So let's just create our first table. So table users, right? Now ID is UID, primary key as well. Next we will add the username, email, and password column to our table so we can finish our SQL table. So let's add the username, which will be a varchar of 255, which is around the amount of character you should have, and it will not be null, and it should be unique. Now email, also a varchar, shouldn't be longer than 255 character, not null as well, and also unique. Now for the last part, password varchar of, we use a big number because we will hash the password in the future, and when you hash the password will become much longer than the original size. So for that we use a big number. This number is 1024, which is around the amount that you will need, and also not null. Great, so this is our fails table, and when we will run our application, this migration will come to place. So let's run our application, and when we run application, this initial migration will run. But now if we want to create a new migration or to add some stuff, we cannot just like create another table right here, call it a products, give it the ID, primary key, the name, varchar of 255. No, we cannot do this and then migrate. It will cause an error because like git commits, you cannot change what has been. You can only build forward. So if we want to add anything, we will take this code out of this and create a new migration. So let's create a new migration file. Let's call it v2 double dashes adding products table dot sql, and now we can add this migration. So this is how it works, how a flyway works. Like Git, you can only build upon each other. If you want to change anything, you add a new migration. You don't change the last migration. So this is how flyway works, and it's amazing. Your first migration is ready when you start, and this is how it's works. Flyway will make stuff a lot easier for us as a developer, as we can just use natural SQL language to create our table easily and fast. In the next lesson, we'll talk about entities and how to use them. Now that we have our database ready, we need to build a bridge between our Java code and our SQL tables. Think about it. Java use object like the user object, but SQL use tables like the user's table. They are like two different languages. The process between connecting them is called ORM, which stands for Object Relational Mapping. It's like a translator that lets Java and SQL talk to each other perfectly. In this lesson, we will learn how to create entities, special Java classes that mirror our database table. An entity is just a Java class that represents one row in our database table. If you have users table, you will have a users entity. When you create a new user object in Java, Spring knows exactly how to save it as new row in your table. But first, we need to add Lombok. This is a library that writes all of the boring code like getter, setter, constructor, and more. It writes all of this for us automatically using simple annotation. So we can focus on the real fun stuff. So now let's add a Lombok dependency to our pom.xml file. So let's open it and let's add it. Now it's called Lombok, just like that. And the group ID is org it project Lombok. Nice. We also mark it as optional because we only need it during development to generate our code. So now let's add the final part for this dependency, which is the optional, and we set it to true. Now let's let Maven take care of it, and great, we have Lombok in our application. Now let's add the Spring Data JPA starter. Spring Data JPA starter is a bundle of everything we need for creating entities and connecting our database to our application easily. So let's add this dependency using dependency, and it's Spring Boot starter data JBC starter Spring Boot wait data JDB JPA. So now let's sync with Maven, and we have our Spring Data JPA up and running. So now let's create our entities. So in the SOSI folder, we create our entities in the Java file. So let's create a new folder called entities, and let's create here all of our entities. So new Java class, and when we create an entity, we will capitalize it and give it a singular name. Like if we have the users table, we call it user because it's an object. So user, hit enter. Now, how does Spring knows that it is an entity? Like it should guess, it should see that it is in the entities folder? No. What's happened is we use the table annotation and we'll tell them exactly which table to look for. In this case, it's the users table. And we also mark it as entity. So we'll know exactly that this is an entity of the table's user. Now we need to add the ID field to the entity. So JPA would know exactly what type our ID is and how to reach it. So we will use ID as a field. So private UUID, as this is the type of our field, and we will call it ID. And we will add the ID annotation and the generate value annotation with the strategy of exactly how the ID is created. So generate value with UUID. So this is our primary key, our identification. The JPA now knows how to reach in our database. Next, we will add the other field that we have in our database. Let's add the username field. So string username. And we also have the email, so private, it's a string as well, email. And the last one is private string password that we have in our database. So this is our entities and how it looks like. Now, if you want to create our database from entities, which is also an option but less recommended for Spring Boot, we will use the column annotation. So add column, and we could add stuff like name, password, and more field like length, and let's set this to 1024. And we could set stuff like nullable to true or false, and a lot more. And by doing this, we could actually create the database from our entities. But notice that it's a more professional way to use flyway migration. It's very much easier to create this migration with pure SQL code. It's faster and it's much easier to get track of our database using flyway migration. So this is essentially how our entities would look like. So this is how we will create entities. But if we are to initialize it and to use it, we'll need to write a constructor, getter, and setter, which is quite a headache, I won't say. It's the boilerplate Java code that is less fun to write. So for that, we use Lombok. Lombok use annotation to make our code much shorter. So let me just show you what we can do. We can just use one annotation to create getters for all of the fields in this class. So let's use add getter, and bam, we have all of the getters in our application in just one line of code. And the same we can do for setter. And let's say we need to create a constructor as well. So we can add the all args constructor. There is a subtle error, but it's because we may want to create an object without initializing all of the fields at the constructor, maybe by using the setter and getter. So for that we use another Lombok annotation, a very useful one, which is no args constructor. So this is our entities. And let's take the product entities that we are created, the product tables, and convert it into entities. So new Java class product, we will create it. Now we will need to add all of the annotation that we have earlier. So let's do it first. Table, and we'll tell it the name will be products. And let's add the entity annotation, the getter, also the setter annotation, also the all-arg constructor, and no args constructor. Now we'll need to create an ID field. So private UUID ID. Now we need to import it. So option enter. Nice. Now let's use the ID annotation and the generate value annotation and generate type. And the strategy will be a generate type of type UUID. Nice. And the other one field which was the name. So string name, not capital. Nice. So this is how we are creating entities. It's fairly simple, as you can see, and it's give us a lot of control with how objects create and how they are saved to the database. And this is one of the best things about Spring Boot, is that you need to do so little to get so much. We just did not so much work, not so much code, just a few lines of code, and we just get all of this functionality, which is frankly amazing. So this is entities, which is one of the best ways of Spring Boot to connect to our database. So in the next one, we'll talk about repositories. So buckle up. Now that we have our user entities, we need a way to talk to the database. In Spring Data JPA, we use repositories. Think of a repository as a remote control for your database table. You don't need to write a long, scary SQL query manually. You just press a button like save or find by ID, and Spring does the rest. In this lesson, we will learn how to create and use these repositories, and now they handle our database operation like a pro. So creating a repository is incredibly simple. We just create an interface and extend the JPA repository. So let's go and create the repository folders. So new and repositories. So here we will keep all of our repositories. So hit enter. Now let's create the user repository. So it's very simple. We'll just need to create an interface and we'll call it user repository. Hit enter. Now all that we need to do is write extend JPA repository and hit enter. Now these repositories use generic, so we will need those braces, and first of all we will tell them which object type our database uses. So for the user repository we'll use the user, let's import it, and we should tell them what ID, what type our ID. So in this case we use UUID for our IDs. So that's all that we need to do, and now we have a lot of functionalities, like a lot. Let's just mark it as our repository so Spring Boot can manage it for us. Great. And that's it. By extending JPA repository, we automatically get a lot of methods like save, delete, and find, all for free. But what if we want to find a user by their email? For that we could use query method. Spring is smart enough to look at the method name and write the SQL queries for us. So let's add the query method for finding the user by their emails. So let's create optional, because there can maybe a user and maybe not a user, so optional of type user, and let's call it find by email with a simple string argument of email. Now it's amazing, we just write it and damn, we have this query. So Spring Boot, and especially Spring Data JPA, has a processing that by conventions that we write our method name, it knows how to create our SQL migration. We can also do other stuff with those conventions, like checking if a user exists or an email exists in our database. So let's do this as well, which will be a boolean because it's true or false. So exists by email, and if we have a user that exists by this email, it will return true. If not, it will return false. But for more complex stuff, we cannot just use the Pinimat. Spring Data JPA naming method convention is amazing. And for the most of the better part, you will not need anything more than that. But if you have a long query that you need to do, you can use the naming convention, but then you will have a very long, a very weird method name. For that we use the query annotation. So let's say we want to find user by their name and order it by their email. Instead of making a long queries to do so, we'll make something very simple. We will use the query annotations. So let's give it a name. Let's use optional because it doesn't have to be of user, and let's call it find users user, and that's around it. Now we will add the query annotation. So query. Now we'll create this in double quote, and here we will do our SQL query. So select everything from users where email is equal to email. This says to Spring that we are using a variable here. So note it, and order by username in asynchronous order, just to make it fun. So this is what we do. But now we'll need to create this variable. So we will add the variable right here, don't we? And then we will have it available. Now the answer is not, because Spring does not know exactly that we are talking about these specific variables. So for this we will use the param annotation, which is for parameter, and we need to tell it what its name. So the name of the variables is email. So right now this is how we can use simple queries or more complex queries in certain scenarios to also use if we don't want to came into the long convention of the JPA naming method. So this is how repositories work. In the next module, we'll talk about NoSQL databases. In this lesson, we are going to set up a completely different kind of database, MongoDB. So far, we have used PostgreSQL, which is a relational database. It uses tables, row, and strict rules. But MongoDB is a document database. It's flexible, fast, and works more like a collection of folders and files. Think of it like this. PostgreSQL is like a formal filing cabinet where every folder must look exactly the same. MongoDB is like a digital folder where you can throw in different types of nodes and it just works. In this lesson, we learn how to get MongoDB running in Docker and connect it to Spring Boot. The great thing about Docker is that we can run multiple databases at one time. We'll just add a MongoDB to our existing Docker Compose file, and it's like adding a second application to your kitchen. So now let's update our Docker Compose file to include MongoDB. So let's head over to the Docker Compose file, and right under services we will add MongoDB. So let's add our MongoDB service right here. So right under services we'll add a new service called MongoDB, and we'll start with the base image of Mongo 7, which is the latest version of MongoDB. Hit enter, and now let's go. Now we'll give it a name and set up the setting for the root credential. These are the super admin settings for our database. So now let's set up our container name and the root user. So container name, and we'll call it ultimate Spring MongoDB. So let's do that, and now let's set up the root user with the environment, and we'll set up a few environment variables for the root user. So let's start with the username. So Mongo initial db root username, and just like that. Then let's give it the username of user123. Now something simple. And finally, let's set up the root password for MongoDB. We'll use something very simple like password123 to keep things consistent and simple. So enter. So you can just copy that and change the end for username to password. So right here, let's change it into password. So we'll pick this part, delete it, and said password. Nice. And as we said, something simple. So password123, just like that. Next, we open the gate, the port for MongoDB. The standard port for the gate is 27017. So let's do this. So ports, it will be something like 27017 in our computer, and in the container it will be 27017 in the container. Now on my computer I have already process running on 2017, so I will switch it up to 2018 so it will work. On your computer it should work on 27017, but if it doesn't, change the port, and this could be the problem. So finally, we need to have the volume so our data won't disappear when we turn off the computer. So now let's map the volume for MongoDB. So just like we did with Postgre, now volumes will be stored at mongo/data_data, and we will put it in data.db/db, and this will be the volumes for application. Lastly, we defined the new volume at the bottom of the file alongside with our existing PostgreSQL data volume. So now let's add the volume definition. So right here, under there, we'll add Mongo_data, just like we did with PostgreSQL. So now let's start the database. We use the same commands as before. Docker will see the new services and start it up for us. So now let's run the docker compose command. So head over to the terminal. So let's head over to the terminal, just like that, and let's run this command. So it will be docker compose app-d, and let's run it. Now it will pull the image from Docker Hub and build our container. Now it may take a while, so I will just speed it up for you. Now we have our application running with Docker, but using a root user for our application is a bit dangerous. It's like giving everyone the master key for your house. Instead, we will create a special application user that can only access our specific database. We will do it using a quick terminal command. So now let's create the new user. I will just paste this command. You can just write it if you want, but this is the command for creating a new user. Right here, we're creating a new user with permissions of read and write for our database. So let's hit enter, and we got okay, which means everything okay and the user is created. So right now let's move on and let's create my mistake. Let's add the new dependency for the MongoDB with Spring Boot. So let's go to the pom.xml file and right here under Spring Data JPA, let's go and add a new dependency. This dependency is a Spring starter for MongoDB. Here we got this, so let's hit enter, and it's from the Spring framework organization. So click enter. Now let's sync it up with Maven, and incredible. So now we also have this up and running. So now finally let's add all of the information to our YAML configuration file. So YAML now right here. So now let's add our Spring Data MongoDB starter. So right under the JPA dependency, let's add a new dependency, and this one is Spring Data MongoDB. So let's click enter and let's go to the Spring framework.boot. Great, let's sync it up with Maven. Nice. Now let's add our credentials in the application.yaml file. Let's add everything that Spring needs to start. So data MongoDB. And now let's add the URI for our database, which will include our credentials. So MongoDB, and we'll add our username, so which is app user colon to the password, which is app password, and we'll have at localhost host dot 27018 and slash ultimate mango slash db, which is our database, and authentication auth source, we'll add this as well, will equal to admin. So this is what we need. Now this is the URI that Spring will use to connect to our database. Now let's add the simple, now let's add the database, so Spring will know exactly which database we are talking about. So database will be the ultimate Spring Boot database. We have this database here, so let's just copy this, paste it right here. So this is all of the configuration that we actually need. Now run the application and everything should work smoothly. So let's try it out. So now we have everything we needed to start up with our MongoDB database. Great. In the next lesson, we'll talk about entities in MongoDB, which is documents, which is very much like entities. So I'll see you in the next. Now that our MongoDB is ready, we need to build our documents. In PostgreSQL, we have entities that match tables. In MongoDB, however, we have documents that match collections. Think of a document as a digital form. You can add as many fields as you want, and it doesn't have to follow strict rules like a table. In this lesson, we'll learn how to create these flexible documents and connect them to Spring Boot. So we have the documents annotation to tell Spring, hey, this class match a collection in MongoDB. We'll start with the product class. So now let's create the product document class. So head over to here. So now let's create a product document class. So head over to the project. Right here in our Java folder, let's create a new folder for MongoDB. So MongoDB, and we'll create a new folder, a new package. Inside this package, let's create a new package for the documents. So documents. Nice. Now in this document, select create a new Java class. So let's create a new Java class for the product document. So now let's annotate this class with the documents annotation that tells Spring which collection this match. We will use the product collection. So now let's add the class level settings. So let's just do this. Right here we'll add the document and we tell them this match the collections of the products, just like that. And finally we declare the product class itself. So let's finish with the class definition. So every documents need a unique identification. In MongoDB we use a string ID, which is MongoDB will automatically generate for us a long unique random string. So now let's define the ID field with the ID annotation. So just right here let's add the ID annotation, and we need to create the private string ID field, just like so. Next we will add a title of our product. We'll use the field annotation if you want the field name in MongoDB to be different from our Java class, but we will keep them the same right here. So now let's add the field, the title field. So private string title. But if you want to use a different name in your Java classes and a different name in your collection, you can do something. You can use the field. So you use the field and you give a name, and you can call it like product dash title. You can do this as well, but right here we don't actually need it, so we will remove this. Now we will add the description. Since MongoDB is a flexible, we can add a long description without worrying about size limitations. So now let's add the description field. So just like the title field, private string of description, just like so. And finally we'll add the price. We'll use a double to handle decimal, like $19.99. So now let's finish up the product class. So private double price, just like that. Now our collection is ready, but we need to create getter and setters for our application and for Spring Boot to use this application as best as possible. But since we are using Glumbook, we can get free of all of this headache and just go up here and add all of the stuff like the getter and the setters. Not like that, my bad. Setters. And we can add also constructor like ours constructor and no args constructor. And just like that, we create our first documents. We're using the documents annotation. Now we have told Spring Boot exactly how to map your data to collection, and with Glumbook we keep our code clean and professional. In the next lesson we are going to create a Mongo repository, which works just like JPA repository but for MongoDB. It's super powerful, so I'll see you there. Now that we have our product documents, we need a way to talk to our MongoDB database. In Spring Data MongoDB, we use Mongo repository. Think of Mongo repository as a remote control for your MongoDB collections. It works just like our JPA repository from Gradle, but it's built specifically for NoSQL. In this lesson, we learn how to create and use these repositories to handle all of our NoSQL database operation. Creating a MongoDB repository is incredibly simple. We just create an interface and extend the Mongo repository. We need to tell Spring two things: which entity the repository is for, which in this case is for product, and what type of ID the entity used, which in this instance is string. So now let's create our product repository interface. So right here in the MongoDB, let's create a new package for our repositories. So repositories. Now in there, let's create our product repository. So interface, and let's call it product repository, just like that. Now we need to extend the MongoDB, the Mongo repository. So extend, and just like that, Mongo repository, just this one. And as you see, it's a generic repository, so we need to add the two stuff. First of all, the entity type, the document type in this case. So in this case, we are using the product. So just like that, and we need to tell them exactly what type of ID we have. So in this case, we have a string ID. So just like that. That's it. By extending MongoDB repository, we automatically get methods like save, delete, and find all for free. But what if you want to find product by its title? We can use query method here as well. Spring is smart enough to look at our method name and write the MongoDB query for us. So now let's add a custom query method for finding a product by its title. So it will be optional, because this product can be and may not be. So if it doesn't return a product, we don't want any error. And it's very simple method name, find by title. Very simple, as you can see, and we'll need to give it the argument of title. It's as simple as that. It's just like, it feels so similar to writing SQL or repositories with a Spring Data JPA. You can do more stuff like optional of product, and you can do something like find by title and price and order by title. And we need to give this the argument of Spring title and string, and my bad, double of price. And just like that, we have get and method. So as you can see, it's incredibly simple. So now we need a place to use our new repository. We'll create a product service class. Think of a product service as the brand of your store. It's where you put all of your business logic, like checking if a product exists before updating its price. So now let's create the product service class. So right here under MongoDB, we'll create the product service class. So new Java class, and we'll create it with a package. Now show you a shortcut to do it in IntelliJ when you create a package and a class at the same time. So you just write the package name, so service, and you put dot and the name of the class. So product service, and just like that you have created a package and and a class at the same time. So as you can see, we have created both at the same time. Cool shortcuts. Now we'll add the service annotation to the Spring. Hey, listen man, this is a service right there. And we'll add all our constructor because we don't want to create the constructor ourselves. Now, to finish up the creation of our product service class, we will need to use our repository. So let's give the field right here for the repository. So for the repository, we can call it product repository as well, just like that. So now let's create a new method to create a new product. So public product will be the return type, and we will call it create products. Now we will get one parameter type product, so product. And now let's return the new product repository. We'll save it. So save and product, and bam, we create the new method. But wait a second. Before we need to create a new product, we need to check out if this product is already exist. And we will check if this exists by its title. So let's add a little if statement. So if product repository find by title product.getTitle.is present, this means that it will find a product with this title, which means we already have this product in our system. In this case, we will throw new runtime exception, and we will say something like product is already exist. And just like that, we have created our first method. So just amazing. We are just to build fully functional NoSQL database layer. With just a few lines of code, you can now save and find product in MongoDB safely and efficiently. You are using the power of Spring Data MongoDB like a true master. In the next module, we are going to dive into web development and see how to build a REST API and a GraphQL API with Spring. So how does the network is working? How does something happen? How does something is sent and then received? This is exactly what we use the HTTP protocol, which stands for Hypertext Transfer Protocol, and is the main way of communication between the backend and the frontend. So in HTTP we use JSON, which is a key value per file format that looks something like that. And it's very good and very easy to send and receive a request with this structure. Now let's go over a few of HTTP most important parts, such as statuses. HTTP status are one of the most important parts of HTTP and help us shape our response accordingly. We have 200, which is stand for OK, 400, which is stand for bad request, 404, which is not found, 201, which is created, 41, which is unauthorized, 403, which is forbidden, and 405, which is method not allowed, 204, no content, and 500, and finally, which is internal server error. So this is everything you need to know to start with HTTP. So let's start with REST, which stands for Representational State of Transfer. And in more simple terms, it's a protocol that lets us handle communication between client and server using HTTP protocol. So REST uses JSON, which can look something like that. Status with 200 or 400 could be okay, and more statuses. A header with some of the data like the access token, which will dive more into details. And also the most important part is the body, which holds information like the ID, name, email, and a lot more. And this is how we use JSON with REST. So, in short, this is how REST works. So, we have talked about databases and the core of Spring Boot. And now, let's talk about the most important part of the application, our API application. And now let's talk about our API, our endpoint that our application exposes Those are actual places that we can use our application. So today we learn how to use REST to create our first feeds. Endpoints are the way for our application to connect to the internet and to make our application visible and more than just a property backend. So now let's go over to the pom.xml file, add a few dependency, and real quick start our work. So right here, we will add a new dependency, and this one will be for the Spring Boot starter. So Spring Boot starter, and this one will be for Web MVC. So click on it. This is the organization, and I will add another dependency, and this one is for validation. We will talk about validation later. So Spring Boot starter, and we will write validation just like that, and we will sync it up with Maven. Now let's create our first endpoint. So now let's create our few first endpoint. So right here, open it, and we'll go to the src folder, main, Java, and we will create our. So now let's create our first endpoint. So right here, under the src folder, main, Java, we will create controllers. Controllers are the Java classes that handles all of the API logic, the incoming request, and return the result. So let's start with the user controller. Now, for Spring Boot to know that this is a controller and to treat it like one, we need to tell that explicitly to Spring. So that we need to use a few annotation that came with the Web MVC starter. So we will use the controller annotation. The controller annotation tells Spring Boot that this is a controller, which means every incoming request will map right into here. But for REST, we have something even better. We have REST controller, which is more explicit for REST operation like get, put, post, receive, delete, all of that stuff. And now we will add another annotation to tell Spring in which endpoint this controller will wait. Like what is the URL will be like. We have http:/application/go. And where does this user controller endpoint will be? Probably in /users. So for that we need to tell Spring that this application map to the /users endpoint. So let's add the request mapping, which map this API to this specific endpoint. So we will use /users for it. And by doing that, we tell Spring to map our controller to this API endpoint. And lastly, we will add the Euler arg constructor, so we will not need to add the constructors ourselves. So right here, we need a few fields. The first one will be for the user repository. And for now, we will keep it as that. Now let's create our first endpoint, our get endpoint, to get all of the users. So dot get, we will use the get mapping annotation, and we will return a list of users, and we will click enter, and it will be a list of all of the users. Nice. So this is our first endpoint. Let's go over it really quick. So first of all, the return type is list of all of the users. This is the name, and we return all of the users from our database. Nice. Really simple, and that's we have our first endpoint. Nice. But there is a little bit of a problem with how we return user, because we have a few properties. If we have a few properties in the user's entity, like ID, username, we have also password, and we don't want to share the password with everyone that wants the list of all of the users. It's highly insecure and super risky, and for that we are using something called DTO, data transfer object. It's a way to convert one object to another object, to map one object to another object, and by doing that we can exclude certain fields that we don't want to have in our final API. So let's create our first DTO. So right here, new, we will use Java class, and for DTOs we'll use records, as they came with a lot of built-in great functions like getter and setter. We don't need to set them ourselves, and we don't need to use Lombok for it. So we'll put us in the DTO dot, and this is the shortcut for creating a new package, and we will call it user DTO, and we'll use the record. And now we will put all of the fields that we actually want. So let's go to the entities, take a look. So let's go over to our entity and we'll take a look at the user entity. We have ID, name, email, and password. We want the ID, the password, the email, the user. We want the ID, the username, the email, but not the password. So we only need those 4 fields. So let's add them. So we could just copy those, but there is a different format for record, so just show you real quick. We have a string and we will put the ID right here. We also have a string of username and we also have string of email, and those are the fields that we want to have and we want to expose to our client. So just like that, we would change the implementation that return regular users to return the user DTO. So user DTO. Now there is error because the user repository find all return a list of all of the users, not users DTOs. So we need to change it. So we will use functional programming. So we will use .map, .stream, .map, and we will map each object to a user DTO. So user will go to a function. Now let's map them. So first of all, we will create a new user DTO with the user name, email, and password property. So user dot get ID, user dot get username, and user dot get email. So user dot get email, and we will map. And because this is one liner and we don't need to return anything, nice. And now we need to convert it into list. So to list. And just like that, we have what we needed. Just a second, let's make it look better, more organized. Each properties on one liner. So let's break it down so it would look better formatted. Yeah, look much better now. Yes, I'm feeling more like that. So we created our so what we did now was really nice. We use our user repository, we return all of the user, then we will change as we don't sort of that is absolutely unnecessary, that and we don't expose stuff that is absolutely risky and high security vulnerability. And for that we use the DTO. Then we change the implementation to use the DTOs by using functional programming. And this is what we got. Really nice. Like it. Now to return for all of this process of mapping each object to a user DTO to a product DTO is tedious. Think that we need to do it one right here, but think that we will need to do it again in other places, like in every single user's endpoint, in every single product endpoint. It's very tedious and we don't want to do this. For that we are using mappers. Mappers are helping us to map DTO to, we can map entities to DTOs and incoming requests to entities and vice versa. So we have a few different ways to create our mapper. We can use mapstruct dependencies, but in this course we will map them manually to really understand what's going on under the hood. So we could just grab all of this code and we could create a new. So we will just create something look very similar to it in a function called toDTO. So let's create our mappers. So right here, new Java class, we put it in the mapper folder and we'll call it user mapper and we'll use the class. So real quick, we'll tell Spring Boot that this is a service, so we could inject it into other classes. Now let's create public. It will return user DTO, but it will call toDTO and it will get a user type. Now we will create a user DTO with user.id, name, and email, just like that. Now let's go over to here. We will add a new field for the user mapper and we will change that, and we could use method reference, so we could use user DTO, so user DTO to DTO. So we will take the user, so user right here, and we will map it. So we will use the mapper to map it. Now we can use a method reference. Nice. So it's look much cleaner, as you can see. But in regular API standard, we don't want to return just the list of users. We need to return a status if the request is gone well, 200 if the request went wrong, 400 or 404 not found, and more stuff like that, because REST is built upon those statuses. Right here, we are returning just a plain user DTO's response, but we need to return a response with the status and the body of the request itself. So for that, we will use the response entity. Response entity, our Spring Boot class, to help us create those endpoints with those status really easily. So we could go right to here and we will add the response type, the return time to response entity. Now this is a generic type and we tell it exactly what we will return, which will be a list of user DTO. So now we need to return a response entity. So let's keep all of those in a list of user DTO. So list of user DTO, and we'll call it users. So this will be the list. We will keep them and we will return response entity okay with the users. Really nice. So now we upgrade our endpoint from just returning a plain user to return a user without the extra fields, and then we will upgrade it to return a status. So now it's a really well structured endpoint. Incredible. So this is your first endpoint. Be proud of yourself. But we can make it even better. You see all of this logic, all of this fetching logic and mapping logic does not belong to the controller. The controller only responsible for getting incoming requests and directing incoming response. That's all. It doesn't need to worry about DTOs, database, repository, all of this stuff. This is for our user service to be worried about. So let's create our service class to handle all of the business and fetching logic. So we'll call it user service, just that. We will add the service annotation, of course, and we will just grab all of the logic from here. We will put it in the user service under the name of get all users. So public will return a list of user DTO and we will call it get all users. And now we will add the user repository right here. So we'll click user repository and we will need to add the all org constructor annotation. So Spring could inject the user repository to our application. So let's just return this logic that we have created. Now we need the user mapper as well. So final, so user mapper, and there you got it. Now we can go to the controller, remove those, as we only need one field, which is the user service. And we can remove all of that, and we can use the user service, and this is the method. Real nice. We have a basic API. We upgraded it with DTOs, then with proper statuses and responses, and then even further with removing all of the logic to a separate place. Incredible. So this looks really clean. As you can see, building stuff with Spring Boot most of the time will look really clean and really good. And that's one of the things I personally most like about Spring Boot. So now let's create our endpoint to get a single user. So we will use the get mapping and we will return our response entity and we will return only one user DTO. So it will be called get user by ID. Let's remove it for a second. Now how exactly does we get the ID? We will get it where exactly, and now that we tell Spring Boot from where to get it. So like earlier when we map our class to this point, we can map our request to a specific place. So right here we can add slash and this is the endpoint. Now most of the time we will get D in the URL of the request. So we need to tell Spring where to actually find it. For that we use those curly braces and in between them we put our property name like D. And now we can actually use this ID that we receive in the URL in our classes, in our controller. But how does we actually get this ID? We know it's in there, but how does we actually get it? We use a special annotation called path variable, which means path in the URL path, and the variable is the ID. So this is the one. And now let's go to the user service and create the basic logic to fetch user by its ID. So user service, a new method, get not by username but by ID, and it will be a string of ID. Let's just change right here from long type to string. So we have our user service, and now let's create the method real quick. It will return a user repository.find by ID. So find by ID. We'll put the ID right here. So then we will map it to the user DTO. So use our user mapper to DTO. But if we don't have a value, we'll return null. But we don't want the user repository. We don't want the user controller to handle if we will return a null value. So instead of null, we will throw a new error. So our auth throw, and it will be a new error. So we will use a lambda to throw this error, and it will be new runtime exception, and we will call it user not found. So we also have the get by ID method. Let's organize it to look better, much better. And now let's return. Now let's create our user, user, call it user, and we will assign it to user service dot find user by ID. And we'll put ID right here, and it's return a user DTO, not a regular user, and we return a response entity OK, which OK is the status for 2. Oh, OK, it's the status for 200, and we have another endpoint. Like yes. Now those are endpoints for getting all of the data. Now we need endpoints to actually create data, to create a new user, and to actually update them. But before that, so great, we have it. But as you can see in our user service, we are throwing an error. And if a user is not found, we throw in this error and all of our application just stop. We actually need to handle all of those exceptions that we are throwing. So for that, we need to create a global exception handler that change those exceptions into something more pleasing for our API, like a 400 or 500 internal server error response. So we can change it from runtime exception to not found exception, which is more explicit. So we will take those exceptions and create now a global handler for those. So right here, new Java class, and this one will be global exception handler. And now we will add the annotation that tells Spring Boot that this is an exception handler. So we will use REST controller advice. This is the exact annotation that tells Spring that this is the control. This is the controller that handles everything that goes wrong, all of the exception. So we will add a new exception handler from the runtime exception. So we could have exception handler, but we will use the runtime exception class. So this will handle the runtime exception, and it will return a response entity with the status. We will use the wildcard because we don't know exactly what is the response entity that we will return. So we get the exception and we will return a response entity with the status of HTTP internal server error. But we didn't find a user, so why does we return an internal server error? Let's return something more meaningful. So return response entity with the status of not found. Great. Now we can make this exception handler even better. We can create our own exceptions to handle them personally, and we can give a much more clearer response. So right here, a new Java class, and we will create exception, and we will call it not found exception. And in the message, we will change it, and we will write our message ourselves. It will be and we will return the message as that. So now let's use it in our user service. Instead of runtime exception, we'll add not found exception, which is much more explicit, and now we can handle it better. So right here, we'll catch all of the not found exception, and we can return much more meaningful response from it. Nice, because we don't want to return for every runtime exception error. We don't want to return not found. Sometimes it's internal error service, sometimes it's a better request. So this is our first exception handler. So we just level up each time our game. We create better endpoints, then more secure, then abstraction of code, then we will add more stuff to it. We're just getting better and better by each second. So now let's add all of the endpoints for creating new resources, like creating new user. So it will be a post mapping, and it will return a response entity of type of save user, and we'll move it just for a second. So we will get a response entity, and it will be the type, and it will call it save user, and will return the DTO to the client in the end. And we will return the user DTOs in the end. So now we need to define how creating user request should look like. So we should have a DTO like create user request. Nice. So let's just create it super fast. In the DTOs folder, right here, we'll create a new record. We'll call it create user request, and we'll add all of the things that we need in the request. We need, first of all, the username, then we need the email, and finally we need the password. Nice. Now here is another important part. To protect our endpoint And to really ensure that we don't receive just empty data, false data that will cause, or null data, and then when we will try to save them into the database, it will cause an error. We will add some validation to all of those fields to validate that we're getting a valid data. So we have the validation dependency that we added in the start of this lesson. So let's add all of the necessary dependencies right here. The first one will be the not null. With the not null, we are ensuring that this field cannot be null, and if it will be null, it will throw an exception before it even reach our controller. The next one will be not empty, which means that this field will have a content in it. And finally, we'll add size, and right here we'll tell what is the size that we want, like maximum character or minimum character. So minimum characters can be around, so minimum characters will be like 2 or 3, and maximum characters would be like 256 or 250. And we can also add a message, so if there is a problem, we can just tell the user something that user name must be between 3 and 250 characters. Forgot how to write character. Between 2 and 3 characters long. We can also add the message to not null, like super fast message. Username cannot be null. Also to the empty message, username cannot be nice. So we can add all of sorts of validation to it with messages and all the stuff. Now let's add the validation right here. This time we will not add all of the message and all of this stuff. It's a little bit tedious right now, so let's just focus in the logic. So not null, not empty. And right here we'll add not null, not empty. And the size will add a minimum of 8 characters. So size will be, main characters will be 8 for security, and max character will be 1024. Now for the email, we have another annotation that we can use, which is the email, which will validate that this is actually an email and not just like a scrub of characters. It could just like check it if you can see the @ symbol and a dot in the email, that this means that this is a valid email. So we have our request, we have our validation. So now let's create it real quick. So now we need to get this request and these parameters from the body of the request. Now we access the body of the request by using request body annotation, and we'll add the valid annotation to validate our data, and we will use the create user request, and we'll call it just request for our request. Now let's create in our user service a new method to save our users. For that we also need to create in our mapper to map for an entity. So public, it will return user, and it will be to entity, and it will map it. So we will use the user builder pattern. So we will use the builder pattern. So now let's just make sure that our users has the builder pattern. We will add it real quick. Builder. Now we can use the builder pattern to make stuff much easier. So right here we'll use user dot builder, and now we will build it real quick. We also should get user request. You create user request type. Nice. Now we'll start with the username. So request username, and the same for the email, and the same for the password. In the future we will hash password because we don't want to store them as plain text in our code. It's really not that secure, And now we can just return it. So we map a user from a DTO to an entity. Nicely. Now let's go to our user service and create a new method called save user. So we'll return a user DTO, and we'll call it save user. And we don't get a user DTO, we'll get a create user request. Call it request. And now let's add all of the logic that should be inside it. So really simple. We will save a user. We will get the user mapper. We will map it into a user. Then we'll use the user repository to save it. So we can just do that. As you can see, we convert it into DTO, and we take this save user, which return a user type to here. And now we can also make it even one liner better. We can just like that, and then we have everything one line, and we have the save user method. So in the controller, we will return a response entity of type OK, response entity type OK, and we will use the user service dot save user with the request. Nice. But now we need to handle a few of those exceptions. So great, we have it right here. So now we can also create the put mapping for updating a user. So for that we need to use the ID. So as we did earlier with the get, we need to know the exact ID. So real quick, public response entity, it will return a user DTO, and now let's call it update user. And in the path variable we have the ID, and in the body we are expecting to get a request DTO. And now we will map it into an entity, save it, and then we'll return the DTO to the client. So right here, user service, a new method, public user DTO, and we will call it update user. We'll get ID and the DTO. First of all, we need to find the user. So we will take this method, we'll take the find by ID, and if we don't have it, we will throw not found exception. Great. And now, after we find the user, we need to create a new mapper to update the user. So it will get the name and the email and will update them. Now actually we need to create another small DTO, yes, a little bit tedious, record, and we'll call it update request. And real quick we'll add string of username and string of email. We can add off the validation, but let's forget about it real quick. Let's focus on the main idea. So we need to get not just a user DTO, we need to get update user update request. So user update request, we call it request, and in the service real quick it should expect a user request. So user update request. So now that we have it, we need to use our mapper to map off the logic. So let's write it here and transfer it into there once we're done. So user dot, so you can just use user dot set username, and we will take the username. We also could use user dot set email, and we'll set the email. So let's just move it because it doesn't actually belong right here. It belongs more in the mapping logic. So to our mapper, I know this is a little line of code and feel a little bit waste, but for abstraction, this is what we need to do. So it will return a user, and we will call it update, and it will get a name, email, and user. So user string for username and string for email, and we will return. We'll have user.update. We will add username. We'll update it with the username. So username right here with the email, and then we'll return this user. Right here in our service, let's use the user mapper, and we'll return a new user DTO, and we will use the user mapper. So user mapper dot update, and we'll add right here the username request username and request email. And now we actually need to save it. So we need user repository dot save. This looks a little bit too long in my opinion, so we could also abstract this, but it's okay for now, we can handle it. So now into our controller right here, we will use this method. So right here we will return response entity of k, and we will add the updated user and the request. Now let's create our final method for our CRUD operation, which is the delete. So delete mapping. In the delete mapping we will also get the ID, so we expect to get it right here, and it will call delete user, and it won't return anything, so and it will not return anything, so the return type will be void. We'll get ID in the path variable, and it's real quick operation, but we want to delegate it into the user service to abstract all of the logic. So public void delete user will get ID, and we will just delete by ID. But first of all, for safety measure, let's make sure that we have this user. So user, so we'll just use user repository find by ID, we'll put ID, and if we don't get ID, we need to throw the exception. Now we will delete the user. So right here we can just use we will delete the user, so user service delete user, and then we will return OK build. Or we can use 40, we can use 204, which is no content. So we can use no content build, which is more suitable to this case. Great. So we create our first endpoint, and then you can see just 50 lines of code, and if we will just like remove all of those imports, it became 47 lines of code. Really nice. This code looks really clean, really abstract. User service looks also really clean, really abstract. And also, as you can see, we have a lot of the time we just searching users right here and throwing you not found error. We can also just use this method, get user by ID every time instead of just every single time searching a user. So let's just change this method to get a regular user, because sometimes we need a user DTOs and sometimes we need a regular user. So let's extract to a method, and we call this method find user by ID. Great. And the return type will be of user, so we will just return it. Nice and easy. So we can use it right here. So find by ID, we'll put ID. Also right here we can use it, and then map, use the map. So can remove this line, and right here just that, and we can use find by ID, we'll put ID right here, and we could use, and instead of mapping it like that, we could map it like that. We'll go right here, we will use user mapper to DTO right here, add it. Nice. So let's go over what we did in this lesson. First of all, we start right here in the controller with a very basic controller. We start with a controller that returns a list of users, and then we updated it to be more secure for user DTO. Then we abstract the logic, then we add a response entity to return a proper response to the client, proper REST response to the client, and then we abstract all of the business logic and all of the fetching logic into the user service. Then we'll learn how to use path variables, how to get to parameters in our ID, how to update, create, and delete resources. So that was all for now, and I'll see you. So I hope you learn a lot, and I'll see you in the next.
So far, we have talked about REST, but REST has a few problems: overloading and underloading. Overloading is when our application asks the server for the information, and the server gives too much information. And underloading is when our application asks for the server for the information and gets too little of it. And for that, needs to make a lot of requests. The solution for those problems is GraphQL. GraphQL is a query language for client-server communication and use mutations and queries. Mutations are everything that change our data. When we update username or a user field or a product or something like that, this is a mutation. A query, on the other hand, is everything that reads the data, like a product price or username. You get the point. So this is GraphQL, and in many modern application is the best option to use.
In the last lesson, we learned what GraphQL is. Now let's build it. Think of Spring GraphQL as a translator that takes those custom grocery list queries and knows exactly where to find the item in our kitchen, which is the database. We are going to define a menu, which is a schema, and then write the code to handle each item on the menu. So in this lesson, we are going to set up a professional GraphQL API. First of all, we need to add a GraphQL toolkit to our project. Spring Boot has a special starter that brings in everything we need. So now let's add the GraphQL dependency to our pom.xml file. So open up the pom.xml file right here, and let's add it. So right under the validation, let's add the new dependency. This will be Spring Boot tail for GraphQL. So GraphQL, and it will be from the org.springframework.boot. Now let's initialize with Maven using Shift, Command, and I in Mac, just like that, and it will download our toolkit. We also want to turn on GraphQL. This is the beautiful web interface that lets us test our queries right in the browser. It's like a sandbox for your data. So now let's start enabling GraphQL in our application.yaml file. So let's head over to this. Right here, SLC folder, resources, we have the YAML file. So here we need to enable it. So under Spring, we will add a new property called GraphQL. So GraphQL. And under this, we will add GraphQL, which is a beautiful web interface. So now let's enable it. So enabled, we will set it to true, and we will set a path to it in the right here in the GraphQL. So we set up our beautiful interface. Every GraphQL API needs a schema. This is the menu that tells the client what the data exists. Every GraphQL API needs a schema. This is the menu that tells the clients what data exists. We write this special file with the ending of .graphqls. We will define what a user looks like and what a product looks like. So now let's create the folder and the schema file. So right in the resources folder, we will create this new file. So GraphQL, and we'll create the GraphQL folder. And now instead of a dot that we did earlier to create a package, right here we are creating a new folder. So for that we'll use the slash, and the file will be the schema file. So hit enter, just like that. First, we defined our data types. Notice the explanation mark. That means that the field is mandatory and will never be empty. So now let's start defining the user type. So let's start by making type, and we'll call it user. So now for this user type we have a few stuff. So first of all we have ID, and we will use the ID type, and we'll add exclamation mark that tell this is an important field. Now we add the username and the email field to our user type. So username, which of type string and cannot be empty, and email is from type string as well and cannot be empty as well. Now let's define the product type with its ID, title and price. So now let's add the product type. So first of all we'll start by the ID, which is ID, and the title, which is a string, of course, string like that, and for the price, which is an integer. So let's use that just like that. Now we define the query type. This is the list of questions that the client is allowed to ask. We'll allow them to ask for a list of all of the users or list of all products. So now let's start the query types in our schema. So right under here, type query, and we will add those. So users will be for getting all of the users, and it will be list of users like that and cannot be empty. And finally we'll add the products field to our query types. This will finish up our schema definition. So now let's finish with the query type. So products, not here, products, and just like we did with the user, we'll do the same with the products. Exclamation mark to tell this field is important. Now we need to write the Java code that fetch the data we use in the controller and the controller annotation and the query mapping annotation. Query mapping annotation tells Spring when someone asks for users on the menu, run this method. So now let's create the user GraphQL controller class. So right here in the controller class, let's create a new controller called user GraphQL controller. So user GraphQL controller. Now let's add the controller and the require a constructor annotation and define the class. So let's start with the class definition. So controller, just like so, and require our constructor. So require our constructor or all args constructor. Both are working. Finally, we add the query mapping method to fetch all of the users from our database. So let's do it. We will use query mapping, so just like that. And let's take the function. So click, it will return a list of users. So, but not just a list of any user, we will use user DTOs because we don't want to expose stuff like password as we discussed earlier. And we call this function users, and we call it in the schema. So just like that. And now we will return, we will use the user repository dot find all users. So we will use the find all, and just like that. Now we have this red line for error, but why does we have this error? This happens because the user repository returned user type and not the user DTO types that we are expecting from here. So we need to map all of those users into user DTOs. So let's do it by using map. So stream dot map, and now we can map the user DTO. So from user we'll go right here, and we will use the user mapper, but we need to have this field right here. So private final user mapper, just like that, and we will map dot to DTO with the user, and we will return it to list. So to list in the end. Now we see this yellow underscore line because we can use much shorter and much better looking way to do so. We're using lambda with method reference, very simple, just like that, and a semicolon in the end. So we create our users method. Incredible. So we have just built a professional GraphQL API. Yes, exactly. This was that simple. You didn't need much and bam, like REST API. You just did it. And this is the magic in Spring Boot. You don't need a lot to get things done. You can write a very little amount of code and create amazing applications. And this is one of the best things about Spring Boot. So this was for GraphQL, and I'll see you. WebSocket is a way to create an instant connection between the server and the client and used mainly in messaging applications like WhatsApp and Instagram. It works by establishing a connection between the client and the server. While we have a connection to one device, we could have multiple devices to be connected with the server, like a group chat. And when someone sends a text, the server gets the request and sends it to everybody else that has this instant connection, no matter the device send or receive. This gives us the option to make instant connection and to make things like messaging and video calls super fast and reliable. In the last lesson, we learned that WebSocket is like a telephone call that stays open. Now, let's build a setup using this technology. Imagine you are in a group chat. When you send a message, everyone else sees it instantly. The server doesn't wait for them to ask for it. It just broadcasts the message to everyone in the room. We are going to use a tool called Stump. Think of Stump as the post office for our telephone call. It helps us organize our message and make sure that they get to the right room or topic. In this lesson, we learn how to build a real-time chat server from scratch. First, we need to add the WebSocket starter to our project. This gives us all of the tools to handle persistent connection. So, now let's add the WebSocket dependency to our pom.xml file. So, head over to the pom.xml file and let's add this new dependency. So, right under the GraphQL dependency, let's add a new dependency. This one will be the Spring Boot starter, but not for validation, but for WebSocket, just like that. And let's take Maven. Now that we have this dependency, we need to configure the WebSocket. We need a configuration file. This is where we set up the room, the topics. We will create a message broker. Think of it as a central hub that receives message and decide which user should receive them. So now let's create the WebSocket config class. So do this. Right here in the SRC folder main Java, let's add new class. We'll call this folder the WebSocket and we will create a new WebSocket config file. So WebSocket config, just like that. We will add two annotations for this class. So the first one will be configuration and the second one will be to enable WebSocket. So this one, not this one. So now we need a configuration file. This is where we set up the room's topics, if you like. We will create a message broker. Think of it as a central hub that receives message and decide which user should receive them. So now let's create the WebSocket configure class. So head over, Java, new, Java class. It will be in the WebSocket folder and it will be called WebSocket config, just like that. We'll add two important annotations. First of all is configuration. The tells Spring this is a configuration file, and the second one will be this one, enable WebSocket message broker. They tell them to enable WebSocket in our application. Now we need this application to implement another configuration app. So we needed to implement WebSocket message broker configure. So it will implement this. Next, now we need to define our address. Any address straight with /topic will be room that users can listen to. Any address starting with /app will be for message user to send to us. So now let's configure the message broker prefix. So just like that, we will add the override to here and create this function public void and we call it configure message broker. So configure message broker, and we have a typo, message broker, nice. And we will take one argument of message broker registry. So message broker registry. Let's call it registry. Now we need to enable the simple broker. So registry dot simple broker. Let's click it and we will add the address. So it will be for topics for all of the listeners. So this will be for the listeners. And now we'll create the one to send with. So registry dot set up listeners, just like that, and we will give it the slash app. And finally we need to register the endpoint. This is the URL where the initial handshake happened. We will call it /ws, short for WebSocket. So now let's register our WebSocket endpoint. So a new method we will need to write. So override public void register stomp endpoint, just like that. And we will need stomp endpoint registry, and we will call it registry as well. Now we need to add the endpoint. So we'll do registry dot add endpoint. It will be WS, which is short for WebSocket, but set allow origin pattern to all, which means everyone can enter. So set allow origin to just like it. Now we need to define what a message look like. It's a simple record that holds the sender name and the text they wrote. So let's create the chat message. So in the WebSocket folder, let's create a new Java class. It will be a record and it will be for the chat message. So chat message, just like that. Bam. In there we'll create a string which will be for the sender, the name of the one who sent it, and one string for the content. Now for the radio station, the controller. When someone sends a message into the server, this class will broadcast it to everyone else. We use message mapping annotation to receive messages and send to annotation to send them back out to the room. So now let's create the chat controller. So right here in the WebSocket, let's create the chat controller, just like that. You will add a simple controller annotation, and when someone sends, now let's use the send to and the message mapping annotations to create our first endpoint. So we'll start with the annotation of message mapping and we'll tell them to map it into the chat. So /chat, and we will send to when someone sends, and it will send to the topic, right? So /topic /messages, just like that. And we will create the function to handle that. So public chat message broadcast, we call it chat message, and it will be message, and it will look very simple, just return the message. Yes, that's all. So this is for WebSocket, and I'll see you in the next one. So security. Today security is the most important thing that we need to consider in our application. We need to make sure that everything is secure, well placed, and well protected. To know what we need to protect, you need to know first of all from what we are protecting. So let's go over of the most important and basic attack that we need to defend of. The first is the SQL injection. The SQL injection happened when we have some fields in our application and they are exploited by a malicious user by inserting a SQL statement to trick our system. For example, adding the quote or 1 equal to 1 to our system, and by doing that, every time the SQL statement evaluate to true and trick our system to think that this user is an admin. Cross-site scripting happens when a malicious user inserts a malicious JavaScript code and then the server save it to the database. And now when another user came to the application and the application reload in the background, our malicious code will run and hurt the user. And finally, the human factor. We are all human and could be easily tricked by an email and linked accidentally on a malicious link. So those are the main attacks that you need to be aware of. And now you know what you need to protect from. In this lesson, we will talk about Spring Security. You can think about Spring Security as a high-tech, secure system for a luxury apartment building. When you first install the system, it's secure by default. Every door is locked, every window is barred, and even the residues are locked out. To make it usable, you need two things: a registry of residents and a security guard at the front desk who knows exactly which key to hand out. In this lesson, we are going to hire exactly what we need for our security guards and create out resident database, ensuring that only the right people get the right keys to your application. First, we need to add the security starter to our project. Think of this like installing a high-tech lock on every door of your application. The moment you add this, Spring will lock everything. If you try to open your application, it will ask for a password. So now let's add Spring Security dependency to your pom.xml file. So let's head over to the pom.xml file and add this new dependency. So pom.xml, and right here let's add the new starter. So dependency, and we will add Spring Boot Starter for security. So Spring Boot Starter, and now we'll add for security right here. Security, just like that. And now let's install it. Great. We need to hash our password. But why exactly does we need to do this? Because right now we are storing the password as plain text in our database, and this is not good. It means that if something happens, we have a security breach in our application, all of the user's passwords are now leaked, and anyone can use them and steal from our users, steal their identity and steal information of our users. For that, we use hashing for our password. We use Bcrypt for it. You can think of Bcrypt as a professional document shader that also happens to be a master puzzle maker. When you password like secret123 into Bcrypt, it shredded it into 1,000 pieces and regrant them into a completely new unrecognizable pattern. Certainly, this process is one way. You can never unshatter the documents to see the original password. Instead, when a user logs in, we shatter their new attempt and see if the attempt is resolving a new puzzle match to the one that we have in the file. This is the golden standard for keeping user data safe. So, now let's create our configuration file to configure the password hashing. So, let's create a new folder called security in the Java. So, main Java, let's create right here a new folder called security. So, we need a security folder, just like that. And in this folder, we need a security configuration file. So, security, or we can call it security configuration or security config. We'll call it config because it's simpler. Now, let's add the configuration annotation. So, just like so. Now we add the beans for the password hash encoder. This is our password scanner that will use Bcrypt. So now let's add the password encoder method. So we will call it public password encoder. So password encoder, and we'll call it password encoder for the method. And we will return new Bcrypt password. So Bcrypt password encoder. So this is the interface and this is the actual implementation. And let's make it a bean so Spring Boot could manage that as so. Now that we have our password encoder, we need to use it to encode our password. So for that, we will go to the mapper when we are mapping out to the user and saving it to the database. Right there, we need to convert the password from a plain text to a hashed Bcrypt. So let's go to the mapper right here to the user mapper. Right here, when we are converting to user, when we are converting the password, we need to add one step. So let's add a private field for the password encoder. So private final password encoder. So we will use this, and we will use all ours constructor just like that. And right here, when we are going to use it, we are going to use the password encoder. So password encoder dot encode to encode our password just like so. And like that, we have hashed our password and make everything much more secure. Now we need to tell Spring Boot, now that we encode our password and make them more secure, we need to tell Spring Guards how to find our member list. In Spring, there is an interface called User Detail Service. You can think of it as a phone book. When someone tries to log in, Spring calls this service and say, hey, do you know a user by the name of Alice? We will look into our database and give Spring the user info. So now let's create our custom user detail service class. So let's head over in the security. Let's create a new class called custom user detail class. So custom user detailed class service, just like that. We will add the service and the all arg constructor annotation and define the class. So let's start with that. Use the service to be managed by Spring and all arg constructor to make the code more beautiful. Now we will add our database repository. This is also the phone book. We will search out to find out the user. So now let's finish up the class setup. With first of all, we'll make sure that this application will implement the interface. So implement user detailed service, just like that, and we will add our database repository. So private final user repository. So now, since we have implemented user data service, there are a few methods that we need to implement in this class. So let's implement these methods, and this is the load by username method. So let's start with that. And now let's implement the search logic. We find the user in our database. If the ER don't exist, we throw an error. So now let's start the load by username method. So now let's implement the method with our logic. So we will return, instead of null, we will return our user. So we will use the user repository and we will find by username. So find by username. And since we don't have it right here, we need to create it in our repository. So let's do it real quick. Go into our repository right here and let's add this new method. So optional user, and we will call it find by username, and one argument of string username, just like that. Now we can get over to here. We have this method and we will use the username just like. And if we don't have it, we will go or else we will throw a new exception. So just like that, or else, and now a lambda method. So throw out this exception. So new username not found exception with user not found, not just like this. And we completed our method. Now, most of the time we don't want to search by their username. We can also search by their emails. So we can switch it out from search by email to search to find by username. So find by email, just like that. But for this occasion, we can use the username. So find by username, just like. Now finally, we need to tell Spring guards which doors are public and which doors are private. We want anyone to be able to register, but only members can buy products. We use a security filter chain to define these rules. It's like a list of instructions for the guards at the front door. So now let's go back to the security config class and add the guards rule. So let's add a new bin in the security config class. Now let's create this new bin right here to be managed by Spring. So bin public security filter chain, we call it filter chain. Now it gets one argument of type HTTP security, just like that, we call it HTTP, and it will throws exception. First we will disable scruffs, which is a type of security checks that we don't need in for our API. So now let's add the craft rule. So return HTTP, and now let's add the craft rule. So ref sref, and with a function call it, and we'll disable it. So just like that. And we can even use a shorter name like a method reference. Now we define which requests are allowed for everyone and which are only for authentication user. So now let's add the authorization rule. So authorization HTTP request. So authentication, which means which one we need to authenticate for, goes like this: auth dot request matcher, and we will match this API request. So API slash auth, we will give everyone the permission, which means right here we'll add permit all, which means everyone can access them. And finally, we will require authentication for every other request and build the filter chain. So now let's finish up the security configuration. So for any other request we will need authentication. So authenticate, just like, unless we will build it. So excellent, you have just locked down your application. You have scrambler to password, a phone book for members, and a guards at the door checking IDs. Your app is a fortress now. In the next lesson, we are going to learn about JWT tokens, which are like digital ID cards that user can carry around after they have logged in. It's a professional way to handle security in modern applications. So, I'll see you there. In this lesson, we add JWT authentication, register, login, and token protected endpoints. The flow will look something like that. User register, log in with his credential, get a JSON Web Token, send the token on every subset request. JWT stands for JSON Web Token. It's a string with three parts: header, payload, and signature, separated by dots. The server creates its own login, sign in with the secret key, and send it to the client. On every request, the client sends it back. The server verifies the signature. If it's valid, the request is authenticated. No session, no database lookup on every request. The token itself contains the user's info. That's why it's stateless. Now, let's add JWT into our pom.xml file. Right under here, right under the Spring Security, we will add those dependency. So it's three dependency that looks something like that. jjwt/API from the group of io.jsonWebToken. So io.jsonWebToken. Now we need to add another tag of the version. So we will use a specific version of 0.11.5. Now we need to add two more dependency with a slight difference from this one. So let's just copy this one, and paste, and now let's change those. Now this is the JWT API. Now we need the JWT implementation. So implum stands for implementation and the same version. Now we need the final one, which is JWT-Jackson. So Jackson, just like that. Now just define a few steps, the scope of the implementation and the Jackson. So the scope of that will be at runtime. So scope runtime, and just like here again, scope at runtime, just like that. Let's sync it up with Maven, and all of those red line are gone. JJWT is the Java JWT library. Three artifacts: the API, the implementation, and the Jackson serializer. API is compile real-time, implementation and Jackson are runtime only. Now let's go to application.yaml and add those properties. So right in the end, now we need to add a few JWT's configuration. So JWT, and first of all need to add the secrets for the server. So secret, and open up the terminal and write this command to create the secret. Open SSL random, so it will create random a string base 64 and write 256 bits. That's what we needed. So hit enter, and now copy that and put it right here. So this is the secret key for our JWT that it will use on the server, and with that it will be much more secure for our users. And that's for the secret. Now let's create another properties for expiration time. We need the expiration time to be like 1 day. Every JWT will be, so expiration will be in 1 day. So 86, 1, 2, 3, 4, 5. This is times in seconds or milliseconds, and just like that. The secret key signs to our token, it must be at least 256 bytes for SH 256. Expiration in milliseconds. The expiration that we wrote is 24 hours. Now let's create a service that handles all JWT operation, generation of tokens, existing claims, and validation. So let's go to the security folder, the Java security folder right here, and create a new class called JWT service. So new Java class JWT service, just like that, and we will add the service annotation. So we got this. Now let's add the secret key and the expiration date in here. So right here we need to take those values from our application.yaml file. So private string for the secret key, so secret key, and private long for our expiration time, expiration, just like that. And we need to add the values, so we will use the value annotation since we have this in our YAML file. So a value, and we will put the path, so just like that. And right here we'll put JWT secret, just like that. And right here as well we'll take the expiration from our YAML file, so value quote that and JWT dot expiration, just like that. and close it. The value annotation injects properties from application.yaml. Spring reads JWT secrets and JWT expression and sets them directly on this field. Now, after all of those fields, let's add this function to generate tokens. So, just like that, public string, the token will be string, we call it generate token, just like that, and it will be of type of user details. User details will be the argument. Now we will return the build JWT tokens. So, return JWTs dot builder. Now let's build this. So, dot set subject will be the user detail dot username, so the user details like comedy get username. Now we will set issue at, so we know, so the token will contain the date that it will start, so new date, and it will be the date it will be created. Now we will set the expiration time, so set expiration, and it will be new date, and we will use system dot current time in milliseconds, the time that we have right now in milliseconds, and we will add to this the expression that we have right here, so expiration, just like that. And just for syntax, kaboom. Now we will add the secret keys, so sign with get sign key, which will be a function that we will create. We will add this later, and signature algorithm will be HS256, just like that. And that's it. Let us now come back, and here we have it. This errors because we didn't implement yet this function. We will implement it in a second. So JWT builder construct the token, set subject, store the username in the payload, sign the token with our secret key using HS256, and compact serialize it to a string. So now let's create a new method for extracting the username and validating the token. So right here, another public string, and we call it extract username, just like that, and we will take the token as the string, so string username, just like that. And it's a very simple function. It will just return the extracted claim. We'll create this function, so extracted, just a second, claim, and we'll add the token, and claims we'll use a method reference dot get subject. So for the subject right here, it's token right here, not username, so just like that, and we will create this function in a bit. Now let's create the is token valid to ensure that the token is valid when we make our calls. So public boolean return true or false is token valid. So just like that, we will take the string as the token, and we'll also take the details service. So user details, just like that. In here we will create final that cannot be changed later, string user name, just like that, and we will extract the username. We will use the extract username method from the token, just like that, and we will return username and dot equals user details dot get username. We will check it out, and also we will check out if token is not expired. So we'll check out first of all if we have a user and if the token is not expired. So is token expired, just like that. Another function that we will create in a bit, just bear with me, and this is the function. Extract username, read the subject claim from the token. If token valid, checks that the username match the token hasn't expired. Both must be true, and if one of them isn't true, the function return false. So now after those methods, let's create the isToken expire, extract claim, and get sign key. All of those methods that we are missing right here. So right under here we create those private methods. So private boolean is token expire, and it will be the token, of course, Spring token. So we will just return extract claim. This is another function that we need to create. So extract not username claim, and we'll give it the token, and we will use claims method reference to get subject, get expiration, and we will make sure that it is before new date. We will make sure that the expiration is before wait now, okay, like that. It's kind of a complex because it said before and this is after. What actually happened is it said before, it state that this token is before, is this date is before the token. Yes, a little bit confusing. Now to another function, but now we'll use a generic for here. Type T, extract claim, right here, capitalize, extract claim right here, a few arguments. First of all, it will be the string, so string token, and second of all, it will be a function. So function, and it will be of type claims, and the special type that we use right here, and we will call it claim resolver. So claim, not that, resolve, and now let's create this. So final, it cannot be changed. Claims, we assign it to JWTs dot builder, and just like that, set signing key, and we will set it with the get key that we need to create. So get sign key, we will create those function just after this one, and dot build. So we will just do it not like this, just a second. Nice. Now we will press claim JWT with the token, and we will get the bodies. So we'll extract it, and finally that's it. And finally we'll return claim resolver dot apply. We will dot apply the claim that we have created right here, just like that. Now let's create the final function get sign key. So right under here, private return type of key, and call it get sign key with no arguments, just like that. Now we need to decode this. So byte array of bits, and we will call it key bytes, like that. And now we will decode it. So decoders dot base 64 decoded. So just like that, we will decode the secret key and add 0 pairs. So to solve it, just like that, we will wrap it in a string value of, to tell them listen up, this is a value of string. So just like that, and now we will return keys dot that, and we will put the key bytes, and now it will return the key. And right here all of our functions are working. And now this error is a simple error of syntax because we have this parentheses over here, so we will remove it, and just like that, this return true or false to check if username is equal to the user detail username, and this check that the token is not expired. So this is it. Now the extract claim is a generic helper. It will parse the token and verify the signature. Every incoming request needs to be checked for JWT token. We do this in a filter. It runs before the controllers on every request. So now let's create the filter. So in the security folder, let's create a new file called JWT authentication filter. So right here, JWT auth filter, just right there, and we will put it as a component. So Spring will know to manage that, just like that, and it will extend the one per request filter class. So one per request filter generate our filters run exactly one per request. The components annotation designed has been so Spring Security can use it. So just inside it class, we will create two new fields, right? The first one will be for private final. This will be injected by Spring Boot JWT service, just like that, and we will call it JWT service. And another private final user detail service, and it will inject our class that implement the user detail service. So right about it. And now let's add the all args constructor, so Spring will take care of those fields. Under that, let's solve this error. So click on it, and we will implement this method. So we need to implement the method, right? So inside of this method, we will use the HTTP server response, not request, response, this one. We will call it response. Now let's create the content of this method. So right here, we need to create a final string, so it cannot be changed later. We'll call it auth header because we will send the JWT in the header. So right here we need to take it from the header. So from the request dot get headers, we'll get the specific header under the name of authorization. So this is where we will find the JWT, and we'll now check a few things. First of all, if the header have something, so auth header equal to null if this doesn't exist, or auth header dot start with bear bear is the start of every JWT. It's the common standard industry, so we need to check if we don't have it. Then right here we will do filter chain that do filter with the request and response just like that, and we need to return just like that. But if we go with that, let's continue. If we have it, we need first of all to cut out all of this bear plus this space, so it's around 7 characters. So we need to create a new string, so final string JWT in case we do have this. So JWT shovel auth header dot substring. We need to cut the string, so we use the substring method for the first 7 characters, just like that. And let's extract the username. So final string cannot be changed later. Username equal to JWT service dot extract username, and we will paste right here the JWT just like that. Well, if the username is not null, we need to check this out. So not null, and that security context holder, so context holder security context holder dot get context dot get authentication is equal to null. So we need to make sure that this is equal to null as well. And if it's true, user details, so we'll create a new variables of type user details. We'll call it, of course, user details, and let's use our own user detail service that we have right here. Dot load by username. We need to find it by the username, so let's paste right here the username just like that, and we'll make another check. So if JWT service is token valid, we need to make sure that the token is valid. So is JWT service is token valid, we will add right here the JWT. First of all is token, and the second one is the user details, so we'll add right here the username, so user details just like that. And if this token is valid, now we need to create a new one. So if this token is actually valid, we need to create a new field called username password authentication token. We'll call it auth token. We'll assign it to, and this is get complicated, new username password token, and inside the constructor we need to put a few things. So first of all, user details, then null, then for the connection we'll put null, and then user details dot get authenticated like that, and we will close the constructor, so just like that. Now under that we'll use the auth token dot set details, and we'll create new web authentication detail source, this one, and build details, and this build this detail with the request, so we'll use this request just like that. And finally, security context holder, we need to get a context, and right here set authentication, we'll set the authentication with the authentication token just like that. And after all of those if statement, we will add right here filter chain, do filter with the request and response just like we did right here. So respond. So if the token is valid, we create authentication token and set it to the security context. That is how Spring knows the user is authenticated for the rest of his request. Now let's create a new configuration file for JWT. So right here, right around here, we will need to create a JWT. In the config file, just around here, we need to add the JWT config stuff. So right around here, we need to add right here when we have the authorization permit all requests authenticated. Just below that, need to add another chain. So we need to add filter before we tell the security chain to create this filter. So this filter will be JWT authentication filter, and user name password authentication filter class. So authentication no token filter, so this is the one dot class just like that. Now let's create this field right here. So private j final JWT authentication filter, and we call it JWT authentication filter, and we need all args constructor right here, and we will add another private field final user detailed service, so detailed service user detailed service as well. just like that. And we need to add another annotation to enable web security. So right here, enable web security. So enable web security, this one, just like that. Now stateless the Spring Boot not to create HTTP session. Fidelity is stateless, so we don't need them. Add the filter before insert our JWT filter before Spring default username password filter. So that's it. Now let's go over in the security config. After the filtration bin, we need to add this bin. So we add the authentication bin. So just around here, a new bin to be managed by Spring public authentication manager. So auth manager. We call it authentication manager, and it will take one argument of authentication config. So authentication configuration, and we'll call it config, shorter name. And before we will put this, we need to tell us that this function is throws exception. So throws exception, just like so. Now we need to return config dot get authentication manager. That's all. Authentication manager is what actually verified credentials during logging. We expose it as bin so we can inject it to our auth controller. Now let's create our auth controller. So right around here in the controller, new class, and we'll call it auth controller. So auth controller, and we will add the annotation right here of first of all REST controller and the request mapping. So the request mapping, and we will map this to /API, it's the convention, and /auth, just like that. Now we will add the all args constructor for it, and we will add a few fields. So private final authentication manager, this one, authentication manager, not this one, private final user detail service, we call it user detail service, and finally the JWT service. So private final JWT service, and all of those will be injected by Spring. Now let's create our logging endpoint. So right here, post mapping of login. Now before we continue, why do we use post? Because we are not creating anything new in our database, we're not saving the user. So the quick answer is that post is the most compatible REST method, unlike the other ones, because it's not like get, because we are not like getting, the user don't get back the information, and it's not updating anything, and it's not deleting anything. So post is the method for creating new resources, which login is one of them. So just to make this clear, now let's create a function. So public response entity, and it's a generic, so it will be a map of string and string. So a map strings and strings, and we'll call just login, nothing too fancy, and we expect to get the login request in the body. So in the request body, this one, we expect to get the login request. So login request. So west, this is request, this is the details that we will create in a bit. So just like that. So let's start it. So authentication manager dot authenticate. Now we need to authenticate the user, and we will authenticate it with a new username password token, and we are sure that get token. So we will request dot get username and request dot get password. So get password. Now let's create real quick these DTOs before we are continuing any further. So just like that, let's go to our DTOs. New Java class, we call it login request, just like that, and we would use the getter setter, just like that, and we will add two fields. So private string username and private string password. So those are the fields that we need in our DTOs. Now let's add a few validation. First of all, we need to make sure that this is not blank and not null, like that. We will do the same right here, not blank, not null, and the minimum size for it. So the length will be at a minimum of 8 characters because we have secure password. So right around here, we need to import the login request class. So we will import it right here. Nice. So right under here, let's create the new detail service. So user detailed service. So this just like that, user detail, and we will assign it to user detail service, our service that it will inject, and we will load by username to find the user. So load by username, and we will use request dot get username, just like that. And now we need to send a string token, so string token, assign it to JWT service, and we will generate the token. When the user enters in, we need to generate the token. So we generate the token by the user details service. So the user details just like so. And finally, we will return response entity dot OK, and in the body we'll return a map of this one, of token and the token. So token and the token right here. So just like that, this is our login function will look like. So we will authentication via authenticate, and it check out the credential against the database, and if they are wrong, it throw out a bad credential exception, and Spring will return 401 automatically. If it is correct, we will generate the token and return it to the client, just like that. So this is how we are creating and using JWTs, and I'll see you in the next one. In this lesson, we will start to learn about testing our Spring application. We will start with unit test. A unit test is the smallest type of test. It tests a single method in a complete isolation. No database, no HTTP, no Spring context, nothing external. The point is speed and isolation. A unit test runs in under 10 milliseconds and tells you immediately whether a single piece of logic is correct. In this lesson, we test pure Java logic, numbers, strings, booleans, and exception. And then Mojito, for replacing real dependency with fake ones. 0 Spring Boot, 0 framework. Spring Boot starter test is already in every Spring Boot project. It bundles JUnit 5, Mojito, and AssertG with a single dependency. Now let's confirm that this is there. So right around in to the pom.xml file, and we should have right here the test starter. So we have the test starter. Now the scope is set to test, so it will not be included in the production jar file. Now let's create the calculator class, a simple logic with no dependency, perfect for our data test. So right here in our Java code, let's create a new folder called utils. So let's create a new folder called utils, and let's create the calculator class. So calculator, just like that. And with plain Java, no Spring Boot, let's add the calculator logic. So let's add a few methods. So first of all, public int add int a, and it will be a very simple method. It will just like return a plus b, nothing too fancy. Now let's add another function, public integer subtract, so subtract and int a, and we have integer not like that, integer a and integer b. And now let's return very simple a minus b, so a minus b, just like that. And let's close this. Now right here we'll create another function called multiplication, so public integer multiply, so not like that, we have a typo, so multiply just like that, and we have integer a and integer b, just like that. And very simple, return a times b, so a times b, just like that. And finally let's create another function called divide, so public, and it will return a double because sometimes the division can cause a floating number. So let's do this. So divide, and we have integer a and integer b. Now let's add the logic, so return a divided by b, and we will assign it to double, so double, just like that. Now before we will continue, we will need to have one check. If the number, if b is equal to 0, this operation is impossible because it is not possible to divide by 0. So let's just check it out. B equal to 0, then we will throw new arithmetic exception error, which will tell cannot divide by 0. So divide by 0, just like. Oh, we have all of our math operations, so now let's go and test them. Now the test file is in the slc/test/java, the same package structure as the production code, but completely separate from it. So we have here the main, and this is the test. So we also have it right here. So now let's add a new test for the calculator. So class calculator test. So let's add a new class, new Java class calculator. Wait, I have a typo right here. Calculator test, just like that. Now we don't need to create anything. Just now let's initialize the constructor. So right here, private final calculator, and we'll call it calculator, and let's initialize it right here. New calculator, nothing fancy, just like that. Now no Spring, pure unit test. So let's create our first test. JUnit runs any method that mark with the test annotation. So when we will create test, we will add the test annotation. So we'll create it, and instead of writing public, all of this, or private, we don't need it. We can just write void when we are talking about test. So void add, we will test the add function, and now after the underscore we will add exactly what we want to test. Like first of all we test the add function, and then we'll specify exactly what we want to add. So it should return correct sum. So return correct sum, just like that. And now let's give it a simple check. So int result, so int result will be equal to calculator dot calculator dot add, and let's add two numbers like 2 and 3, just like that. Now we need to ensure that everything is running. And now for the test part. So right here, let's add our assertion. So we need to assert equals, so we need to assert that it is equals, so equals for, this is, here we are putting, wait, before that, right here we need to make sure that we are importing the right method. So it import static method. Now you need to choose. Now don't choose this one, this is not the right one, choose this one, from org.getunit.jupyter API. So right here, this is the one we need to import. Now the result we are expecting we put first. So in this case 2 plus 3 equal to 5, and right here we put the result that we actually got. So let's run this test right here, and in the console all of the tests are pass. Nice. Now let's create a few more tests. So let's continue. Let's create tests for the subtract and multiply. So just like that, test annotation void, and we will test the subtract. So we first of all put the name of what we want to test, so subtract, and underscore, and what it should return. So it should return correct differences. So return correct difference. So just like that. And right here let's add our logic. So we need first of all to store our result. So int result equal to calculator dot subtract, and let's put 10 and 4, and of course the result should be 6. So we need to assert that equal 6, it's the result that we are expecting, and the result right here. So let's create one more before we will run it. So test void multiply. So multiply right here underscore, and it should return correct multiplication. So multiplication, just like that. So let's make it also simple. So int result equal to calculator dot multiply, just like that. And now the first number will be 3, and the other number should be 7. In multiplication it doesn't really matter, right here. And now let's make our assertion. So assert equals, now we put our result, which is 21, and our result right here. Now let's run all of our tests just like here, and we could use these shortcuts of Control, Shift, and R, and everything is pass. Incredible. Now let's go over to our string test. So Spring operation are full of edge cases. So let's build a greeting formatter and test each one of those edges. So first of all, let's create in this main Java utils folder, let's create a new file for the string. So let's call that strings utils. Nice. Now let's create the format function. So let's create a greet function. So public, it will return string, and we call it greet, and it will get the name. So it will make something like, if your name is Alice, hello Alice, so something like that. So return hello and comma, and now we will put right here the name and plus another comma followed by exclamation mark, just like that. So this is the baseline, but now we need to add a test to make sure that everything is working. So first of all, let's start with trimmed our string. So we need to trim our string to make sure that we don't have spaces. Like, let's show you right here. When you have something, when you have strings, you have like the name right here and that. But what if you have a lot of spaces right here? You don't want to have something like hello, comma, and these use spaces or spaces right here. You don't want, this is not what you want. So trim removes all of those spaces and just trim them actually, and trim them and make it so you have only the text left, right? So we will use the string trim function. So right here, name dot trim, just like that. Now we need to capitalize our name. Let's say someone wrote Alice like that and not like that. We need to capitalize, and let's say someone wrote Alice like that or Alice like that. We need to capitalize the first letter, and the capitalize function capitalize the first letter, and all of the other letters is just make them lowercase. So just like that, let's create string. Let's call it capitalize. So capitalize and d, just like that. And let's use this function like that. So we will use the trimmed substring, and we'll take the first substring, so 1 0 to 1, which is the first substring, and we will make it to uppercase, just like that. And now let's continue. Let's add the rest of the string. So trimmed dot substring will take all of the other substrings, so we will take from 1 on. This is the begin index, and if we not tell them the end index like 2, it will take from 1 on. And then let's just make them to lowercase, just like. And actually we can just remove all of this logic to a separate capitalize method. So let's create a new method called capitalize, and we can test that as well. So public string capitalize, it's very useful method. So to get string of str or string, so we'll get a string and we will return a capitalized string. So return, and we will return this part. So copy that to here, we can make it up just like that, and we replace that with string and string, just like that. And this is a very useful method. So right here we will replace all of this by the capitalized method with the name. And let's make this method private because we use it only inside of SysMesa, but we can make it public so we can also test it. So let's make it public as well, and semicolon, and bam. And instead of just the name, we'll put it right the capitalized, and just like that we have it. So now let's test it. We'll start first of all by the happy path, like where everything is going perfect, when we don't have any problem, just like that. So let's go over and create our Spring unit test file. So right here, new, not Kotlin, Java class, and this Java class will be for the string utils test. So create it. Now let's initialize the string multiplication. So string utils, the ones we have just create. So utils. Ensure that this is the one that we have created right here, this one, and not any other ones, because yes. Let's call it string utils, and let's initialize it with the new keyword of string utils, just like that. Now let's start to testing it. So test void and the name of the function that you are testing. So greet underscore, and it should return correct greeting. So correct greeting, just like that. And now let's test the method. So we will assert equals, now import this method from the JUnit API, and now first of all we put the result that we want, and then the method. So we will put hello Alice and exclamation mark, just like that. Now let's use the function. So string utils dot greet, and now inside of here we will put the name, so Alice, just like it should be. So now let's run the test, and everything should work perfectly, just like that. Alright, now let's create the other test. So we will test two things at one time. We'll test first of all the spaces, if we have name like something like that, Alice, like that, and we also test the capitalize. So we will write Alice like that, and to challenge it more, we will write Alice like that. So let's do this. So let's create this new test. So test void grid, the name of the function, underscore, and it should trim white spaces. Just a second, I have a typo. White spaces and capitalize, capitalize. I don't have power. As the just like that. I capitalize a little, just like that. Now we need to assert equals, and first of all, our result will be as this one. So hello Alice exclamation mark, and now let's use the function. So string utils, just like that. We will call the greet function, and just like that, as we said, Alice, and let's challenge it even more. So let's create another test before we run it, and this test will be for the other function that we have created in the string util for the capitalize function. But we actually kind of test the capitalize function right here, but we also want to give it a separate for looking exactly like if it does do it correctly. So right here in the string util test void capitalize, so capitalize, and it should make the leather, oh wait, to make the first letter, and we test both of those stuff. Now let's test our last function. So let's run the entire test right here, and it's failed for some reason. So the reason that it failed is that it is not removed white spaces, it did not trim. So what does this mean? We have a problem in our code. So let's go over to our string util. We have two main problems. First of all, it does not trim the name. So, and that's because we did a problem, and we inserted the name right here instead of the trimmed. So we need to insert this trimmed, and now let's check it out one more time, and everything is running nice and as it should be. So this is how we test strings. Now for the next part we will test booleans, so let's do this. So let's go to the string utils. We will make all of those tests also right here. So right in the strings util, let's add a new method which will tell is an email verified. So it will be just very simple boolean. So public boolean is email valid, just like that, and we will get string email, and it will just very simple, it return if the email is not null, and email dot contains the at symbol, and email contains. So it's very simple, just like to tell the email shouldn't be null, and the email should be at like every email should have like email at com. So we have a dot and that by and we not. So let's go to utils to test that. So right here, let's add those tests. So right here, another test void, and it checks the is email valid, just like that, underscore, and it should return true for a valid email. So it should return true for valid email, just like that. And now let's assert it. So we'll use a new assertion called assert true, and let's import this method again from the junit.jupyter API, this one, and we will use this. So utils, string utils dot is valid, email valid, and we will make the API path. So let's create this new email. So email at email.com, so it should run. And let's create a few more tests for when we have an email without a column, dot, or an at symbol. And let's create another test for what's happened in case the email is null. So just let's do it fast. So test void is email valid, it should return false for unvalid email. So let's do it really quick. Assert, and let's import it again from the JUnit, and let's just put right here from the strings util dot is valid email, and let's put invalid email. So not valid at email, just like that, and this is a not valid email. And lastly, let's see what's happened if it is not. So another test void is email valid, and it should return false for null. So just like that right here, assert false, and let's use the function. So string utils dot is email valid, and let's just use a simple null value. So no, just like that. Now let's run all these tests and they should pass. So 1, 2, 3, and all of the tests are passing. Nice. Now we need to test for exceptions. What's happened when something does not go right? Like in our calculator class, when we try to divide by 0, like how does we test that if we are trying to divide by 0, this exception really been thrown? So let's show you how to do this. So right here in the test, let's go right here and create a new test. So a new test, and this one is for the divide. So divide, and it should throw error when dividing. Just real quick, when I type dividing by 0, just like so. First of all, exception, so arithmetic exception, let's call it exception, and it will equal to assert throw. So assert throw is the JUnit method for throw stuff, throws. Now let's go. Now let's import it from the API, just like that, and let's go right here and let's put our function. So first of all, we put what we are expecting to get, as we did with all of the other stuff. So we expect to get arithmetic exception class type. So this is what we are expecting to get, and let's use a lambda to run our calculator divide method. So let's do it real quick, and we'll use calculator.divide, and let's try 10, and we divide it by 0. Now this is an error, so let's assert that the message that we get from the exception is an error. So so we need to assert equal that the message is the exact one that we put right here. So cannot divide it by 0. So cannot divide by 0 at mark, just like that. And now let's put our message that we accept to get exception for exception dot get message, just like that. Now let's run this test, and it's run, which means if we try to divide by 0, it throws the error that we are expecting it to throw. Nice. Now let's go forward. Now calculators has no dependency, and it's very easy to test, but for our real services it depends on a lot of stuff, on repositories, email, payment, gateway, a lot of stuff. A lot of things can go wrong. But how can we test which one fault it is? If we just want to test the user service or animal service, and we don't actually want it to be sent to send an email and then to check if everything is working. So for that we use mocks. Mocks are used to simulate an operation that we don't want to happen in our test, like sending an email or calling an external API or doing anything that is not part of the logic that our unit tests are built for. So for that we have Mojito. So Mojito creates a few versions of any dependency. We tell it exactly what to return. Then test our classes as if our real dependency was there. Now let's build user service that depends on user repository. Then mock the repository so we can test the service logic without touching the database. So we already have this repository and all of those other stuff. So let's test our user. So let's go to our user service and create a new method. So right here in the services we have the user service. So let's create a new method for testing, not actual one that we will use in a Spring application. So let's create a new one for a greeting. So public, let's remove this, just string greeting, and we will take string of username. Now before we need to get the greeting, we need to make a few stuff first. So first of all, let's return and let's check if this user is actually exists. So user repository dot find by username, put the username right here, and let's check it out. Now let's map this username. Let's show you that we have it. So user goes to this string. So we'll come back just like that, and let's concatenate it with the user dash username, get username, and let's add explanation mark just like that, explanation mark. And if we don't find it, we'll use or else we will return user not found, just like that. A very simple function. So now let's go and test it out. So go to the test folder, create new, we will call it mock test, and right here let's add the user service. So private final user service, and let's initialize it real quick, user service, and let's initialize it with new user service. Nothing too crazy. And we need to pass the user repositories. So let's give Spring to handle all of this stuff for us. So just like that. And we will put the all args constructor. So all args constructor. So we will not need to worry about it. So right there, let's start the test. So before we can start the test, we need to first of all add Mojito. So right here, right above it, let's add it. So extend with, and now we'll tell them to extend Mojito extension. So Mojito extension class. And right here we'll need to mock the user repositories and we'll inject the mock to the user service. So right here, let's add the private final user repository, and now let's mock it. So let's use the mock annotation and let's use the inject mock. So inject mock to inject this mock of user repository right into the user service. And now let's create our test. So test void greeting, and it should return welcome when a user leaves. So, and it should return welcome when user exists, like that. And let's do it fast. Now let's start by creating a mock user. So right around here, let's create a mock user. So user, and let's call it fake user, and let's create a new user. So new fake user. So let's give him the ID of 1. Let's give him the name of Alice, and let's give him an email of alice at gmail.1.3. Just like that, we create a mock user. Now we tell Spring when, and let's import this method, when user repositories, when this function dot find by username, when this function is called with the value of Alice, you should then return. So then return, then you should return optional of fake user, which means we just return this. So it should return optional of, and now let's put the fake user. So what's happened when this function is called from the user repository, called this function with the value of Alice, it will then return this mock value. So just like that. Now let's add the mock stuff. So first of all, the mock looks something like that. When something happened, you then do something. And in this case, when something happened, like when the user repository called the find by username method with the specific name of Alice, when this specific method happened, we should return the value it should return. It's first of all optional, because this method return optional of fake user, so it will return this. So now let's test this method. So string result, and now let's use the user service dot greeting method with the Alice name, just like that. Now we get the result. Now let's assert them. So assert equals, let's import it from JUnit, just like that, and let's assert that we get welcome back Alice. So welcome back Alice, just like that. And now let's put here our result. This is what we are this is what we are expecting, and this is what we are getting. So let's run it. REST API test verify HTTP behavior, collect status code, response bodies, headers without needing a real server running. We use mock MVC to simulate HTTP requests. We have testing the product controller from our REST lesson. We will verify get returns a list ports create a product, and we will get 404 for unknown IDs. So let's create our test. So right here in the SRC folder under the tests, let's create a new controller. So let's create our test for REST. So let's create the product controller test class right here, and let's add a few annotation. So we will add the Spring test annotation that loads the application context. So Spring boot test, and it loads our Spring boot context so we can actually test it. And we will add auto config mock. So okay, אני צריך לחתוך אנחנו צריכים את האוטו. 3, 2, 1, go. And next we will add our profile. So we'll tell active profile, and we'll put this profile for test, so it will be easier to switch between development and testing. So just like that. Oh no, it's okay. את זה אנחנו נמחוק, אנחנו פשוט נעשה ספרינג בוט טסט. זה הכל? אוקיי, 3, 2, 1, נמשיך. And right now, let's go on and create our first few tests. So, right here, let's create our first test. So, first of all, we need mock MVC before we start the test. So, private mock MVC, mock MVC. This is allowing us to create mock requests to HTTPs and to mock the use of just mock request. And let's start with the test. So void, and let's use the get product method. Get product, and it should return the product with 200 status. So just like that. And now let's create the actual test. So first of all, we need to save to the repository one product. So we will use the product repository. So product repository, we need to give it right here. So private product repository, just like that. So now we need to save the product to the database so we can use that to perform the HTTP request and to fetch this product. So we will use product repository dot save method, and we will use the builder pattern to create new product. So product dot builder, and in between the builder and the build, we will add a few stuff. First of all, the title, we will add title, and this title will be laptop, and we will add price 999.99, just like that. And now we save it to the database. Next, we need to perform a mock HTTP request, and we can do this by using the mock. So we finished this course. It was a pleasure for me to help you along this journey. If you have anything that you think can be used of improvements, I would love to hear it down in the comments. I also love you to tell friends and family about this course and local businesses that you know that really try to grow big and become better in today's online present and needs a fresh, brand new website that help establish their brand. I would love you to tell them about the Polaris Studio. And this is for today's course, and I will see you in the next one.